Hey guys, and welcome back. Today we are going to be talking about something called nuclear chemistry. Now, we've been talking about the atom and also the periodic table, isotopes of the atom. And so when we talk about nuclear chemistry, we're going to be dealing with the nucleus of the atom. So nuclear chemistry means we're dealing with the nucleus of the atom. So we're going to go ahead and jump into it. Now we're going to watch this video together in class. If you don't come to the Zoom meeting, this will be embedded in the slideshow that you can watch. Basically, this was a Russian spy who was assassinated, and he was actually assassinated by radiation poisoning. So he was injected with a little pellet that was radioactive, and as the element that was inside that began to decay, it started to scramble his DNA, and he actually died because of it. And there is no way to really reverse that radiation poisoning. So it's a very interesting video. I highly suggest you watch it if you didn't come to the Zoom meeting with me today. So we will skip over that. But anyway, today we're talking about radioactive decay, and that's when an unstable atom's nucleus spontaneously changes by emitting radiation. And these include 3 different particles. So we're going to be talking about alpha particles, beta particles, and gamma rays. And if you are a fan of the Incredible Hulk, you might know the term gamma ray or gamma radiation. That's what the Incredible Hulk is exposed to that gives him his superpowers, and we'll talk about that today. So transmutation is something that occurs when one element changes into another element. So remember yesterday when we were talking about isotopes, isotopes are the same atom of the same element, they just change in the number of neutrons that they have in their nucleus. Today we're going to talk about what happens when the number of protons changes and when these elements go through their decay. So Ernest Rutherford and Frederick Soddy, they were able to perform transmutation in 1901. So these were chemists that were performing this experiment. And then when alpha and beta decay occur, a daughter atom is a different element than the parent atom. So they were able to make this occur. It also occurs naturally on the planet, but basically one element or an atom of an element can decay or change into another element, and we're going to talk about how to figure out what those elements will be. So when we write nuclear reaction equations, these are just going to be some of the notations that we'll see. The X would be the parent atom, so what we start with, and then the Y will be the daughter atom, so the new element. The A will be the atomic mass, and then Z is your atomic number. And just a reminder, because it's very important we know and make sure we know, atomic number is our number of protons. It tells us the identity of the element. Okay, so that's going to be very key here. So really quickly, radiation is damaging to living organisms. So what we're talking about today with radioactive decay, this is actually radiation that's being kicked off as these atoms are decaying into other elements. And radiation can hurt our cells. It can scramble our DNA. But that radiation can be stopped depending on the type of decay that's happening. So alpha particles that are kicked off during alpha decay, they can be stopped by paper because they're pretty large and they won't pass through. So basically, they're the lowest energy particle. They don't have that much energy behind them, and they can be stopped by paper. So if somebody were to shoot at you with an alpha ray gun, you could hold up a piece of paper and stop it. Beta particles, they can be stopped by wood or aluminum foil, so a little bit higher energy. It takes a little bit more than a piece of paper to stop those. And then gamma particles have to be stopped by lead, steel, or concrete. Whatever you're trying to protect yourself, the gamma radiation, whatever you want to protect yourself from, it has to be thick because gamma rays are high energy and they can penetrate things like paper and wood. So if you needed to protect yourself, you would need to wear like a lead vest or get behind a concrete wall. Now, when you have an x-ray done, if you've ever broken a bone or had to have something on your body x-rayed, if you think about it, the x-ray technician is never in the room with you, right? And they usually definitely will cover you with some kind of protective covering, the area of your body that's not being x-rayed, because those x-rays do pass through you and pass through your cells and can scramble up your DNA. Now, for radiation, especially for low level radiation, it's more of the chronic exposure that will hurt you. So for an x-ray technician who's doing x-rays all day, they need to be outside of the room so they're not getting exposed. But if you're having, 1 or 2 x-rays done, chances are it's not going to hurt you. So over time, overexposure can be damaging to your cells. So let's talk about alpha decay first. This is the most common type of radioactive decay, and this is when the parent atom emits an alpha particle from the nucleus. It's made up of 2 protons and 2 neutrons. Because of this, we just refer to it as a helium nucleus. So basically, the atom is losing the equivalent of a helium nucleus, and so we notate it as our parent is having whatever atom it is or element it is, it will lose an atomic mass of 4 because there's 2 protons and 2 neutrons, and its atomic number will decrease by 2 because it's losing 2 protons and it's losing an atomic mass of 4. Because helium has an atomic number of 2 and typically its atomic mass is 4, then we just refer to an alpha particle as a helium nucleus. So you're basically losing an atom of helium. So let's take a look at what this looks like in practice. So what does that mean for you guys? What do you have to be able to identify? Okay, so here we have our element uranium. Uranium is an element that will go through radioactive decay. It's actually the element that we use in nuclear power plants, and we'll talk about that more tomorrow. But here, remember, this is our nuclide symbol. So we have our atomic number on the bottom. So our atomic number of uranium is 92. And then on the top, we have our atomic mass, which is 238. So in this example, I would say, okay, uranium is going through an alpha decay. Tell me what the new element will be, okay? Well, first of all, we have to know that we're kicking off a helium atom, right? We're kicking off the helium nucleus. So our uranium nucleus is going to lose 2 protons, and we're going to lose an atomic mass of 4, okay? Now, alpha decay is pretty easy. Since we're losing this in our nucleus, all we have to do is make sure these numbers go down by the correct number of units here. So 238, we're losing 4 from that number, and 92, we're losing 2, okay? Now, let's find out what this would be. So how would we go about doing this? Well, number 1, we're going to do our subtraction, right? So we know our new atomic mass is going to be 238 minus 4. So our new mass should be 234, okay? So the new mass of our element is going to be 234. What we are really concerned with is what is our new atomic number going to be? Since we're losing 2 protons, we're going to go from an atomic number of 92 to an atomic number of 2. So we're going to need to go into our periodic table, and we are going to need to find the atomic or the element that has the atomic number 90, right? So remember our atomic number on the top, and they are in order of increasing atomic number. So we went from 92 to 90, right? So 90 is our new atomic number. So our new element is thorium, okay? So thorium is going to be our new element. So our answer here is going to be thorium-234, okay? So that's how you do it. So if it goes through an alpha decay, you just subtract 4 from the top number, 2 from the bottom number, and then of course we know that bottom number is our atomic number, so that gives us our new atomic number, our new number of protons, which gives us, of course, the identity of our new element, which is thorium. So we would say uranium-238 goes through an alpha decay to turn into thorium-234, okay? All right, next up is beta decay. So beta decay is when a neutron changes to a proton and an electron. The electron is then ejected from the nucleus, and this is the symbol for a beta decay. So we have our electron, and because we're kicking off this electron, remember electrons have no mass, so since we're only kicking off an electron, we're not losing any mass here. Okay, so our atomic mass is not going to change. Okay, so let's take a look at what this looks like if we were to do an example. So here we have carbon 14, so our atomic number for carbon is 6, and our mass is 14. And here we're undergoing a beta decay. Now this is where it can get tricky, because with our alpha decay, you just have to subtract the numbers, and then you're fine, you figure out your new element. With beta decay, we have a neutron in our nucleus that is changing into a proton, okay? So it's changing from a neutron into a proton. And because we're increasing the number of protons, here our atomic number is going to go up by 1, okay? So in beta decay, atomic number goes up by 1. And because the only thing being kicked off is our electron, and our electron doesn't have mass, the mass will stay the same, okay? So we need to go to our periodic table, and we need to find the element that has an atomic number of 7, which will be nitrogen. Okay, so nitrogen has an atomic number of 7. So if carbon undergoes a beta decay where it increases its atomic number by 1, we are going to end up with a nitrogen, and this is just nitrogen 14, because 14, again, we're not changing the atomic mass in a beta decay. Okay? And then last but certainly not least, we have gamma radiation. This occurs after an alpha or beta decay. So the nucleus is excited, it has extra energy, and the gamma ray is released in the form of a photon, and a photon is just a ray of light. Okay, so we're releasing light energy here. No particle gets released, so the daughter atom is the same as the parent. Okay, so nothing is changing here. Gamma radiation, remember, is the most damaging, but it's also the easiest to remember. So here we have our element. So it's 66, so let's go on the periodic table and find our element who has an atomic number of 66. And it's right here, it's dysprosium. So dysprosium is our element. And if our dysprosium goes underneath or undergoes a gamma radiation, nothing is changing. All that we're doing is emitting the energy that is in the nucleus. So we're still going to have dysprosium 152. So if I'd ask you, okay, this element undergoes gamma radiation, what are we going to wind up with? It's the same element, same atomic number, same atomic mass, easiest one to remember. Okay? So that's it for today. We're going to do some practice after you guys get done with taking your notes. But of course, as always, if you need any help, let me know, and I'll catch you guys in the next one.